So welcome to this tutorial from EIZO on calibrating the CG319X with ColorNavigator 7. So in this tutorial we're going to be using ColorNavigator 7 to calibrate the CG319 in a post-production environment. And that is, we have our computer connected to, in this case, an Ultra Studio, but it could be a Bluefish or an Asia interface device which will send the reference pictures from Resolve, in this case, to our CG319. And then we have our EIZO GUI monitor as well for our menu. So there's obviously you can have dual displays, but in this case it's a simple setup. So to do this we need to go and start ColorNavigator 7 from the main windows down here. And you'll get this screen come up, and so you can just go and click OK. And now ColorNavigator 7 has booted up with the information on the GUI monitor here for us. So you can see we've actually selected the Cal2 slot and it's recognised the CG319. So in this tutorial we're going to do it in two parts. The first part, we're going to correlate the internal sensor with the C300 spectrophotometer. So the C300 spectrophotometer is a very high-end 2 nanometer reference spectrophotometer, and that will give the correction data for the colorimeter, so we can go and do profiling and accurately calibrate the CG319. So if you're using a colorimeter, you always need to make sure you're using the correct offsets, and those offsets are created by using a spectro of some form or another. So to do that, we go into monitor settings, built-in sensor correlation, and then that will start up the correlation. So you can see at the moment it's on the default of user, so we just click built-in sensor correlation. We select the measurement device, in this case it's a C300, so there's quite a few different choices that you have available to you in the ColorNavigator 7, from the high-end probes to some of the more entry-level probes. For these wide gamut displays you really do need to use a high-quality spectrophotometer to do this and to make it as accurate as possible. And then we hit the arrow key to go OK. You make sure your probe is in the center, so you can also use an alignment probe alignment graphic as well. And then once you're happy with your probe and it's flush to the screen, you can click OK. And now ColorNavigator 7 has got the probe has come down. It's created a patch in the middle of the screen for you, so it's taking care of all that test pattern generator work, and it'll go and start prepare and to run through the probe correlation for you. This takes just a few minutes to do. The spectro is quite slow compared to a colorimeter, but it's highly accurate. So we'll let this go and we'll come back to it, won't be a moment. So it's coming down to the end now. So what we have here now is the correlation data that has been compiled by the measurement of the C300 and the internal sensor. And once you're happy with that, you just simply go finish. And then you hit the red X box. And that's the correlation of the internal sensor to the C300 completed. So before we start to go and do the calibration, ColorNavigator 7 is actually originated for the photographic world, where it was connected, the monitor was connected to the main graphics card output. But in our post-production workflows and video workflows, we should be connected to an external device which will bypass the ICC profiles and the graphics card within the computer. So to enable the correct working of ColorNavigator 7 in this workflow, we need to go and do something very important. We need to go into the Preferences and go down in the General tab all the way down to the bottom, and we need to click this Do Not Apply an ICC Profile. And then we can go and exit out of that. What happens in ColorNavigator 7 being designed for an ICC profile photographic workflow is that it expects to be connected to the graphics card. But in this case we're not connected to the graphics card, so therefore we only have our main GUI monitor on there. So in effect what we want to do now is to ensure that no ICC profiles are created and stored on our GUI, which in fact should have its own ICC profile for calibration. So what we're going to do now is to go and calibrate our Cal2 slot to Rec 709 for our colour grading work. So we can do that by going into the target settings, and we can create a new target. And we go and enter that manually. So in this case, we're going to be going for 100 nits. We're going to obviously leave our black level at minimum. We want the highest contrast ratio. And the colour temperature we're going for is D65, the standard colour temperature of Rec 709. The gamma EOTF, in this case, we're going to use a pure power curve of 2.4, which is what we normally do for calibrating to Rec 709 for a display. Our priority should be on standard here. Certainly don't use grey balance. Grey balance will tend to lift the black level up, but we want it on standard. The colour gamut, of course, we want to go and choose BT.709 or Rec 709. sRGB is the same colour gamut. The EOTF is different, but the colour primaries are the same. But in this case, we've just got the BT709. If you are going to be calibrating to a standard which is slightly outside of the native gamut of the monitor, say for instance DCI P3, where you might find that the green primary is just very small amount out, then you select gamut clipping. So gamut clipping will ensure that the colours are mapped correctly to that colour space that you're calibrating to. Certainly with Rec 2020 you would select gamut clipping on. It doesn't really have any effect in this situation because the native gamut of the CG319X is much greater than what Rec 709 is. So once we're happy with that, we can go and give it a name, and we can call this Rec 709. And we can also set the colour mode name here as well, so we can call this Rec 709 and maybe user, just to differentiate it from the other Rec 709. So this is the same for all monitors using the ColorNavigator 7 to do that. And then once we're happy with that, we can go and do finish. So now we have our target that we've got, our 100 nits, D65, a 2.4 gamma curve, and the BT709. So once we're happy with that, we simply hit the calibrate button. And in this case, we're going to be choosing the built-in sensor. And you'll see when we choose the built-in sensor that the user data is being applied from the C300 and it gives the date and the time. And then we simply hit the arrow key, and then we go and proceed to do the calibration. So once we do this, the ColorNavigator will start preparing, the sensor will come down, and then it'll start performing its calibration. If you've got light coming over the sensor from a practical or something like that, then you should make sure to cover that sensor up so there's no flare getting behind it. It's always a good thing to do. So this will take a few moments to do, a few minutes, and then we'll come back to that. So it's just coming up now and it's doing the grayscale balance and going through from black to white through the EOTF. It's already completed the colour primary correction. And now it goes and measures those colours to make sure everything's okay. And once that's done, the calibration is then completed. And then you get the results coming onto the screen here. So you can see the target and the actual results of what the calibration was performed. So once you've done that, click that to finish. You'll also see now we have our Rec 709 user down here in the Cal slot. And once we're happy with that, we can then go and close. So that's how you calibrate the EIZO monitor using ColorNavigator 7 for post-production and the Rec 709 workflow. So what we're going to do now is actually also go and verify this calibration using the CR300 and the CR100, CR100 being a colorimeter, to go and verify and run 1,000 patch verification just to double check and see what sort of results we've got. So here we have the results of the 1,000 patch test run for Rec 709. You can see the vast majority of the gamut here are filled with green dots. And green dots mean in colour space that the delta E 2000 errors are less than 1. You will find some orange dots that are around, and if we look at those, you can see here that's got a delta E error of 1.01, so it's orange and it's just over the limit of 1 for a green dot, but still basically it's an imperceptible error. So all in all, a very good result for that. So if we look at the perceptual view of that, we can see also similar sort of a scene here, but really importantly, we can actually have a look at the volumetric view of the response of the entire colour volume of the CG319 after the ColorNavigator 7. Remember, ColorNavigator 7 is a 1D LUT and a matrix, so it's not a 3D LUT to do the complete non-linear corrections within a colour volume. But all in all, you can see that we still get very good results here. Just got a few of those little orange dots here, which are around that delta E1 still, and around the very black areas as well. You get the slightly increased delta E errors, but overall in the entire colour volume, it's a pretty good result. So that's the results that you get when calibrating the CG319X with the internal probe that's been correlated to a high quality spectra like the CR300, and using ColorNavigator 7 to calibrate the monitor for Rec 709.